All right, today's lesson we're going to talk about graphing radical functions. Parent functions, that basically just means the two basic types we're going to talk about is a square root, which is going to be an example of my first one. And the picture onto the second one over here to the side is going to be a cube root. Okay, so let's go back at square roots. Square roots, the most basic square root will always start in the middle at 0, 0. And then if it's a positive square root, it'll go up and to the right. Okay, and it kind of looks like a sideways U, but only half of it. So what you need to know about a square root is that a square root will have a starting point, and then if it's positive, it curves up and to the right. If it is a negative square root of x, then instead of going up and to the right, it's going to go down and to the right. Okay, cube root. Cube root, you'll notice this one doesn't have a starting point. It has arrows on both ends, which means it fills the entire screen. So this one has what I call a center point. And the center point is right there in the middle for the most basic one. So it has a center point. And if it's positive, it's going to start down on the left, go to the middle, and then curve and go up and to the right. Now, if we take the cube root and we make it a negative cube root, then it's going to be just flipped. So it's going to start on the left at the top, curve, and then go down on the right side. Okay. We are going to ask you some review topics that we've already talked about, so I do want to kind of discuss these so that we remember them. We are going to ask you to write down the domain and range, and remember domain is x numbers, and you go from left to right. Range is y numbers, and for the range, you start at the bottom and then go to the top. Around the domain and range, you have to decide the notation. Is the notation going to be a parentheses or bracket? If you use a parentheses, that would be for open circles or infinity symbols. Brackets are going to be used for closed circle. Now, the next review topic we have is transformations. I have a generic function typed here for you. At the beginning, it says f of x equals negative. So if there's a negative in front, then that means reflection over the x-axis. If there's not a negative in front, then you don't write anything. There's no reflection. That just means it's normal. If there's a number in front of the square root, that's what I'm going to call the letter A. If that number is larger than 1, that means vertical stretch. If the number is less than 1, that means vertical shrink. If the number is exactly 1, you don't write anything. You don't write stretch or shrink. Inside with x, we have the letter h. The number inside the radical, that means left or right, and it's always opposite of how it looks. So if you have negative h, that means go to the right. If you have positive h, that means go to the left. At the end, outside of the radical, we have the letter k. K is exactly how it looks. If it's negative, you write down. If it's positive, you write up. So then let's move on to our example. Okay, to help us graph these radical functions, I'm going to use Desmos. Okay, so that's the first thing I'm going to do is go to Desmos. So I'm going to switch my screen here. And I'm going to type in, square root of x minus 6. Okay, so here I go. Square root, and then x, and then I'm going to space out and type in minus 6. Hold on, let me fix my x here. Okay, then I'm going to look at my picture here. So I'll adjust my screen. And here's my picture. You're going to notice that we have a starting point right here at 0, -6. And it's curving up and to the right. So now let's go look at the questions we need to answer. Okay, it says h of 4. So basically, I'm telling you the x number is 4. You need to go tell me the y number. So I'm going to go here on Desmos. I'm going to go to the x-axis for 4, come down till it touches my picture. And then you're going to notice that, well, probably easier than that. Let's go to the t-table. Scratch that. So let's go to the gear. So the gear symbol, and then I'm going to pick t-table. And then I'm going to change this number to 4. And if I change the number to 4, you're going to notice it tells me straight across from that it is -4. So my answer for this one is -4. Now I'll do the same thing for 9. So I'm going to come over here and I'm going to change that into the number 9. Oh, let me type it in here. Hold on. And then if I go straight across from 9, it says the answer is -3. Okay, we said our starting point was 0, 6, so I'm going to plot that. Then I'm going to plot this as an ordered pair, 4, -4. So 4, -4. And then I'm going to plot 9, -3. And then I'll be able to draw my picture. So now let's answer the questions to the side. The domain. Well, if I start on the left and I work my way into the right to the picture, so I'm starting here, working my way in, and the very first place I'm going to hit is at the starting point, which the starting point has an x value of 0. That is a closed circle, so I'm going to put a bracket around 0. On the right side, if I start and work my way in, I'm going to hit an arrow, and an arrow means infinity, and it's on the right, so it's positive. Around infinity goes parentheses. Okay. Range. Range is y numbers, so we're going to start at the bottom and work our way up. And the very first place I'm going to hit is the y number -6. Closed circle, so I'm going to put a bracket. If I start at the top and work my way down, I'm going to hit an arrow. An arrow means positive infinity because we're going up. And around infinity, we put a parentheses. So let me get rid of all these little marks here so they don't interfere with my picture. Transformations. For the transformations, the only thing I have to deal with is this -6 at the end, and the -6 at the end means down 6. And we are done. So now let's go to the next one. The cube root of x plus 4. So to get cube root on Desmos, when you have the keyboard pulled up here, you want to go over to functions. And when you click functions, you want to scroll all the way to the very bottom where it says nth root. And then if you pick nth root, then it will allow you to type in 3 for the index number. And then here we get to type in x plus 4. And then I'll adjust my screen. And you notice with cube roots don't have a starting point. They have a center, and it fills my entire screen. And to me, it looks like my center point is right here at -4, 0. So let's pull up my t-table and let's see what we're looking for. We are looking for g of -5. So I'm going to go here to my t-table and I'm going to change this into -5. Whoops, sorry. Should go back, whatever. And when I type in -5, it tells me the answer is -1. Okay, and then we're going to do g of 4. So we're going to go here and we're going to change that to the number 4. And when I do that, it tells me the y answer is 2. Okay, and then remember we said our center was at -4, 0. So I'm going to plot that. And then I'm going to plot these as ordered pairs. So -5, -1. And then 4, 2. And then I'm going to kind of draw the picture that we have on our graph. And I'm done. Now, technically, you can pick any points you want to plot for the graph. Just as long as you find them from the t-table, then you are completely fine. Domain. You will notice on the left and the right side, we both have arrows. So arrows mean infinity. So -infinity to +infinity. And around infinities goes parentheses. And then same thing with the range. You're going to notice from bottom to top, you hit an arrow. So it's going to be infinity, -infinity to +infinity. Transformations. The only transformation I have to deal with is the -4 inside. And if it's inside, it's left or right and opposite of what it looks. So you would say left 4. Done. Now, example number two, we don't have to make a graph anymore. All we're doing is describing the transformations. So the first thing I notice is there's a number out in front. Number out in front means stretch or shrink. And since 1/2 is less than 1, that means you would say vertical shrink. Inside the root, that's left or right. It's the opposite of how it looks. So for this one, you would say left 3. The number outside at the end, that's up or down. It's exactly how it looks. So up 5. Okay, B. For this one, I have a negative out in front. Oops, negative out in front means reflection over the x-axis. Remember, inside is left or right, opposite of how it looks. So here we would say right 1. At the end is up or down, exactly how it looks. So down 7. Now, C and D is where it gets a little bit tricky because you will notice inside the radical, it doesn't have 1x. It has a number in front of it. Okay, so what we have to do is we have to do some work here because I can only do left or right movement when it's a 1x. So you're going to notice here that I have a 16. And if I think of using the distributive property, or GCF that looks like distributive property, you're going to notice, ooh, I can take a 16 out of each one. So that would leave me with x minus 2. And then you're going to say, ooh, I know what the square root of 16 is. The square root of 16 is really 4. So the 4 goes on the outside, out in front of the root. And then I have x minus 2 inside and the plus 10 on the outside. Now I can list out my transformations. And I'd say, ooh, number in front is stretch or shrink. This one is larger than 1, so I would say vertical stretch. Inside, I would go right 2. And at the end, I would go up 10. Okay, last one. Same thing. Oh, doesn't have 1x, so it has an 8. So I can notice, oh, both numbers are divisible by 8. So then I have 8 parentheses x plus 2. And then I can do the cube root of 8. So if I did the cube root of 8, that would give me 2. So I'd have 2 cube root of x plus 2. And then once again, the number in front, it's larger than 1. So I would say vertical stretch. And inside is opposite. So I would say left 2. Done. Okay, my last example here is I'm going to give you the picture and we are going to write the radical function. So the first thing you have to do is you have to decide, is it a square root or a cube root? So on A, it has a starting point, so that means it's going to be a square root. For square roots, I would identify the starting point. So I would say my starting point is -5 and -4. It goes up and to the right, so there's no negative out in front because there's no reflection. So I'm just going to say f of x. You can use whatever letters you want, but here I would just go f of x, and then we have square root x. And then here my x number is -5, but remember we have to write it opposite. So then underneath the root, I would put +5. And then my y value is -4. And remember, up or down is exactly the same. And then you're done. So let's go to the next one. On this one, you're going to notice that it doesn't have a starting point. It actually fills the entire screen, which makes it a cube root. Cube roots, you will have to have not a starting point, but a center point. And my center point, I labeled it right there on the graph, looks like it's at -1, -3. Now this one thing we have to remember, and we can scroll back up to the top to look at it, is deciding whether there needs to be a negative in front. So if I scroll back up here to the top, you're going to notice in purple is my one that has a negative in front. And that means it starts on the top on the left side. So if I come down to this picture and I'm going to say, I'm on the left side right over here, and this part is on the top. So I'm going to say, yes, indeed, there has been a reflection. So when I'm writing my answer for this one, I have to have a negative in front of my cube root. And then remember, inside you would have opposite, so write it as +1. And at the end, you have -3. Done. Thanks.